Hello, welcome back. Today we're going to be talking about rotations, and by the end of this video you should be able to rotate a figure 90 degrees, 180 degrees, and 270 degrees around the origin. We've got one vocabulary word to look at, and that word is the origin. The origin is the center of the coordinate plane, which is the point 0, 0. Let's take a look at three rotations, a 90 degrees, 180 degrees, and a 270 degree rotation. Now I've got this shape right here, this triangle, and I'm going to rotate this triangle around the point that is the origin. In other words, this little point in the center, I'm going to take my triangle and I'm going to rotate it 90 degrees around the center, and it'll land right here. So that's a 90 degree rotation about the origin. Now if I take that figure and I rotate it 90 more degrees, I'll get a 180 degree rotation about the origin. And if I rotate 90 more degrees, I'll get a 270 degree rotation, and 90 more degrees is a 360 degree rotation, which we really don't have to do because 360 degrees makes the triangle land back on itself. In order to graph a rotation about the origin accurately, there are three formulas we can use to rotate each point in that figure. First one is we take our x values and our y values and we flip their order and make it yx instead of xy. And we change the y values sign from positive to negative or negative to positive. This is a 90 degree rotation. If we flip both of the signs but not the order, it creates a 180 degree rotation. If we change their order but this time change the sign on just the x, it creates a 270 degree rotation. Note that, again, these formulas only work if we're rotating about the origin. Now, if these formulas don't make 100% sense right now, that's okay. Just go ahead and write them down, and we're going to use them in a second for a couple of examples. Now, for the first example, I'm going to rotate the figure below by 90 degrees about the origin. Then I'm going to list the coordinates of the image. Now, I went ahead and wrote down the formula for a 90 degree rotation. Anytime you're doing rotation, it's a good idea to write down the formula as your very first step. Now the next thing I'm going to do, now that I have the formula written down, is I'm going to label my points. If your points aren't already labeled, it's a good idea to just go ahead and label them A, B, and C. So I know that A is the point 2, 4. B is the point 4, 1, and C is the point 2, 2. Now, instead of trying to rotate those points 90 degrees visually, I'm just going to use my formula to find A prime, B prime, and C prime of my rotation. So A prime, I take the x and y values according to our formula, and I switch their order. Notice the x goes in the y spot and the y goes in the x spot. Additionally, notice how the y goes from a positive y to a negative y. That means that we change the sign on the y. So when I take 2, 4, it's going to become 4, 2, but our original y value is going to change signs, so it's going to become a negative 4. Likewise, b going to b prime is going to go from 4, 1 to negative 1. Positive 4. And C is going to go to C prime from 2, 2 to negative 2, 2. Now that we have the coordinates of our rotated points, we're going to go ahead and graph those and see if it indeed does look like a 90 degree rotation. So negative 4, 2, negative 4, 2. A prime. Negative 1, 4. B prime. And negative 2, 2, C prime. So we connect our dots, and you'll notice the triangle does look like the original triangle, but it's been rotated around the origin by 90 degrees. Go ahead and try this one on your own, pausing the video, and press play when you're ready to see the answer. By the way, we're going to take the exact same points we used in the past, and this time we're going to rotate them 180 degrees. So A is going to go to A prime. Notice that when we rotate A 180 degrees, the X and the Y change signs. They both become negative. Likewise, if they were both negative, they would have both become positive. So 2, 4 becomes negative 2, negative 4. 4, 1 becomes negative 4, negative 1. 2, 2 becomes negative 2, negative 2. So these should be the coordinates of our rotated figure. So we're just going to go ahead and graph those. Negative 2, negative 4, A prime. Negative 4, negative 1, B prime. And negative 2, negative 2, C prime. When we connect our dots, it should look like the same triangle, but has been rotated 180 degrees around the origin. So now we're going to take the exact same shape, and this time we're going to rotate it 270 degrees about the origin. Then we're going to list the coordinates of the image. Go ahead and work the example out, pressing pause, and when you're ready to see the answer, please press play. So if we look at the formula, we notice that the X and Y values again switch places, but this time the X changes sign, going from positive X to negative X. Consequently, if it was a negative X, it would go to a positive X. So in other words, it just changes sign. So let's take a look. 2, 4 becomes 4, negative 2. 4, 1 becomes 1, negative 4. 2, 2 becomes 2, negative 2. So let's go ahead and graph those points. 4, negative 2, A prime. 1, negative 4, B prime. And 2, negative 2, C prime. When we connect our dots, it should look like our original triangle was rotated 270 degrees around the origin.